Homework helps for the multiple choice section, part B. There were questions about the odds, so I'll start with some of the odds. Number 29, they give you f of x equals e to the 3x plus 1, and they want you to find the value of x. That is, that's the slope of the tangent line is equal to 2. So slope of the tangent line means derivative, which means we've got to find f prime. So f prime of x, we've got the derivative of e to the 3x would be 3e to the 3x. Derivative of 1 is 0. And they want to know, where is that equal to 2? So we set it equal to 2. So now it's algebra 2. We can go ahead and divide both sides by 3. So e to the 3x equals 2/3, and take the ln of both sides. So 3x equals ln of 2/3, and divide both sides by 3. Plug that into your calculator, and it ought to work for you. All right, number 31. We're going to leave that one for the moment because I need to do related rates with you. We'll do that probably when we come back from spring break. We'll do related rates. Number 33. We've got f and g that are differentiable functions, and h of x equals f of g of x. We need to find h prime of a. So we've got a composition of functions. To find the derivative of a composition of functions is the chain rule. So h prime of x, let's think about derivatives of chain rules. So you do the derivative of the outside, so f prime of g of x, times the derivative of the inside, g prime of x. And we're looking for h prime of a, so f prime of g of a times g prime of a. And go to the information they give you. G of a is equal to, where is it? I can't find it. Okay, g prime of a is equal to b. So we've got f prime of g of a times b. And then we've got g of a is equal to c. There it is. So we can change that to a c. So f prime of c equals, my eyes are so old anymore, it's hard for me to see these little primes. F prime of c is equal to 6 times b, so 6b. All right, moving on. We're looking at number 35. And we're using trapezoidal rule. So you had to go back and look at what the trapezoidal rule is. So we've got the integral from 0 to 3 of e to the x dx. Thank goodness they gave us a nice one. And n equals 4 subintervals. So using the trapezoidal rule, we've got, let's see, b minus a, so 3 over n is 4 times 2, so 8. So look up your trapezoidal rule, friends. If you're not sure how I got 3/8, go look and find the trapezoidal rule, write it down, and come back. And then we've got e to the 3/4. Well, if n is 4, and we're doing 3 subintervals, I'm sorry, 4 subintervals, but we're going from 0 to 3. That makes each interval's width equal to 3/4. So this will be e to the 0 plus 2e to the 3/4 plus 2e to the 3/2. We're adding 3/4 plus 2e to the 9/4 plus e to the 3rd. And that ought to give you Well, do it in your calculator because you'll get that decimal. 19.972. All right, 37. 37, I actually need to ask Mr. This was 35. Mr. Klein about 37. He told me we didn't need to know L'Hopital's rule, but you need L'Hopital's rule to do 37. So put that one aside for a moment. 39. What are we doing on 39? Oh, these are cross-sectional areas. Again, I have to ask Mr. Klein about that one because I don't know if we're doing cross-sectional areas. 41. 41. I don't know why I have nothing for 41. At which of the following values does x have a relative minimum value? All right, so you've got f prime 41. F prime of x equals ln x minus x plus 2. Need to set that equal to 0. So on your calculators, we need to get really good at using our calculators since the AP test will be on the computer only now. We've got ln x, so ln x, close the bracket, minus x plus 2. And we're going to graph it, do a zoom 6. And I've got this funny thing here. We're wondering where it's equal to 0. So we're going to zoom in on it because it looks like it's going to be 0 in 2 locations. So let's zoom in. Let's see, I'm going to zoom in right around there. Okay, so the graph zoomed in looks something like this. So I'm going, this is the derivative. So at some value here, I don't know what that is, I have to find that. It's going from negative to positive. So negative to positive, that's what gives it a relative minimum. So on your calculator, here you go, watch this. We're going to find the 0. So we go to math, I believe, and, oh darn it, how did I do this? Oh, it's under, I'm sorry. You're gonna go to calc, so second trace, and you wanna find the 0, so number 2. And they're asking you, down here at the bottom it says left bound, so the left side of the graph, we wanna be on the left side of where it crosses the x-axis and hit enter. Then it asks for a right bound, so arrow over to somewhere on the right side of where it crosses the x-axis, and then hit enter. And it gives you a guesstimate of where the 0 is. It says it's at 0.1585934, and so on and so forth. So that would be our guess. It looks like it lines up with D, multiple choice part D. So that's how to use that on your calculator. And then we've got number 43. 43. So we've got, let's do, oh, this will be the last question on this segment. Number 43, we've got the integral f of x equals the integral of the cotangent of x dx from 0 to pi. And they give you that f of pi over 6 equals 1, and they want you to find f of 1. So the integral of the cotangent, we've got, that would be ln of the absolute value of sine x plus c. Look up on your chart. We need to find c though, so that's where we use this information. So f of pi over 6, this is f of x here, sorry, it wasn't clear. F of pi over 6, ln of the absolute value of sine pi over 6 plus c equals 1. The sine at pi over 6, 1/2, so the ln of 1/2 plus c equals 1. And when you solve for c using your calculator, you get c equals 1.69. So our equation, f of x, equals the ln of the absolute value of sine x plus 1.69. They're asking for f of 1. So plug that into your calculator. Sine 1 plus 1.69. All right. And I'll end this segment here.